Please work. Okay, and we're starting. So today's presentation is very important. Probably the most important presentation of the whole seminar, at least for me. I end up having 36 slides, and it's about management. Whether you manage project, product, team, career, main ideas. You see, I tried to separate them in color. So first is about clarity and focus. Crystal clear understanding of the requirements, involve all business stakeholders into the planning process, make sure they agree on the plan. Crystal clear understanding of priorities, what's important and what's nice to have, and concentrate only on important features and sacrifice the rest. You'll see it, I'll go into details of all this. Next, simplify, simplify, simplify. Split big job into small pieces, small steps, grow a project as a child from a few features to a full featured product. Seems like evident ideas, but people violate these principles all the time. Military style hierarchical management is not effective. And this is something people don't understand, but it's true. And this is actually coming from Drucker, from like classical management. And I don't know why, like even in our company and previous employments, they give us some military style books on, I don't know, military style doesn't work. Respect workers, leverage their brains, give them freedom to be effective, to communicate and collaborate. So leverage their brains, that's the most important. Give people tasks that match their abilities. Again, this is very important. And create safe and engaging atmosphere. Okay, so these are main ideas. This is kind of table of contents of these slides. So first, begin with the end of mind and begin with what client need, not like from what you think, like the best way to do things. Splitting big problems into small doable steps, split into buckets. First principle thinking. Well, this is difficult because usually people tend to do what other people do, and you have to go against the crowd. This is about simplicity, and this is like one of the main thing which I've learned in life. Simplicity, sacrifice for simplicity, think about simplicity, spend time to make things simple. Okay, we'll talk about that. A growing project as a child. Again, this is kind of don't do waterfall, instead do agile, right? So make a small minimal project and then grow it. And then on the other side, we have project management process. Well, today there are so many project managers and there are books on project management, and they defined how it's supposed to be done, created tools like DevOps, Jira, whatever. But in practice, I found you can use very simple tools. You can use text editor or Excel and have the same, if not better results. So, well, I'll talk about it. Vision and enthusiasm, very important. There are books about this. Unique abilities. People are different, and you need to understand unique abilities of different people and utilize them, not asking a person who is good at doing A, not asking him to do B, which he cannot do, and not asking everybody to be the same. Managing career, get promoted into leadership. I guess it's related to managing in general, so I just at some point decided to add this slide here. And then we go in some books and resources. There's a Parkinson law, which was absolutely essential to my education. Brooks law, Peter Drucker and his theories, 1 Minute Manager, which started the whole series of books with millions and millions in print. Minute Manager meets the monkey. Monkey is the next move. We'll talk about it. Power, like, and mindset of growth. Getting Things Done by David Allen. Well, these are basically lists of what needs to be done. which is done by DevOps, but he created his own tools. 7 characteristics of weak product management. We'll talk about this. Quotes, holacracy, and human performance technology. Okay, so first, begin with the end in mind. This phrase is habit number 2 in this famous book by Stephen Covey. If you haven't read it, shame on you. Buy it, read it, listen to it. There are interviews, YouTube videos. There was a whole store of Stephen Covey's stuff on Wall Street area when I worked there. It's amazing, and this advice is absolutely essential. You need to have very clear vision of what you're doing, not where you are today and what you can do today. This is nothing. I mean, if you don't have the skills, you can learn the skills. If you don't have resources, you can get the resources. But you need to first figure out very clearly where you're going and why and what you're trying to get at the end. The same idea is in this book by Eric Rice, The Lean Startup. So Rice has experienced 2 startup failures, and he attributed the error in both cases as working forward from technology instead of working backward from the business results, your business results you're trying to achieve. So first you need to figure out this end, what you're trying to achieve, and then you go backward, and this is what you do, and you don't do anything else. So main ideas in this book, which I highly, highly recommend. Begin with the customers in the form of interviews and research discovery. So try to find out what the customers actually really want. Build a minimum viable product, MVP, and test and iterate quickly to adjust to customers' need. And he also recommended to use the 5 why approach. So for example, somebody tells that he wants something like he wants A, and you ask, well, why you want A? And he says, well, because of B. Well, and why B? Well, because of C. And so you go why, and to reach the core of the issue. So you need to really, really understand what you're doing. Okay, this is a very important lesson. I had it on my website for a long time, and this is actually my personal history. So I was a student in Moscow. It was in Russia in 1975, first year in college, and we were sent to collect vegetables, specifically carrots. So the task was simple. We were separated in pairs, and each pair had 120 meters long row of carrots. So you see this red row and then blue row, and we had like 6 rows side by side. And this was kind of the norm we were supposed to do in one day. So we're supposed to collect all these carrots, put them in baskets, and then pour baskets into big bags. And there were 6 pairs, so each pair has 1 row. And we were working side by side like runners at a sport competition. At the end of the day, nobody finished even like half of the norm. And it was taking 2 days to finish the norm, right? And this was going on for several days. And then our leader, our manager, well, he was just a first year postgraduate student. His name was Victor. And he made a very simple adjustment. And it was really magical. So what he did, instead of giving each pair of students 1 long row, he gave them 6 short rows. So first pair got like square like this, and so on. You see those squares. And it's the same job, it's just split differently a little bit. Same amount of work. But this day, the whole field was finished by 2 p.m., like from 9 to 2 p.m. So it took only 5 hours to do what before was taking 2 full days, 16 hours. So this is about 3 times increase in productivity without any incentives. And by the way, we were very proud students, like we knew math and physics, and we thought it's absolutely beneath us to collect dirty vegetables. So nobody wanted to work. So we were sitting, telling jokes and so on, but somehow the whole field was done, and it was done like very, very fast. And how it felt that, well, you start working on 1 row, and pretty soon you see that you can reach the middle of the row. So you decide, okay, we'll finish to the middle and make a break. But then you go through the middle and your basket, well, we didn't have steel buckets, we had baskets. So you see the basket is like half full. So say, okay, well, let's like fill it up. And then you making a break, but you see, oh, it's already a very short distance to the end of this short row. So you decide to finish it. And when you finish it, you take a break. And then you look how long it took you to make this one piece, and you can estimate how long it will take you the next one. And I don't know, the whole work becomes easier because you see the progress and it becomes manageable. And I don't know, I just saw the result. The work started to feel manageable. Everybody rather enjoyed. It was very addictive. And it's a very simple technique. What's interesting, you don't have to pay people for that. You don't have to be clever. All you have to do is to split the work in small pieces. It's absolutely amazing management principle. Uh, there's a couple of applications of the same principle. So one is how you write a book. Many people tried to write a book and failed. And this is the approach from a wonderful course by Steve Manning. And the course title is How to Write a Book on Anything in 14 Days or Less, guaranteed. It's an old course. Maybe you can find it online somewhere. I have it. I bought it, like, and I absolutely loved it. So his idea was you create a title, which is end in mind, right? So what do you want to do? Create a list of 10 chapters, create a list of topics inside those chapters. So now you have 10 by 10, let's say about 100 buckets. And then you fill these buckets with some content. It doesn't have to be in order. The buckets do not have to relate to each other in any way. You don't edit anything. You just fill the bucket with some raw material. And you don't stop, you don't go back, you don't edit. Because the problem with editing is that people start the first chapter and then they write the first paragraph and then they return and rewrite the first paragraph. And they like it's very difficult to move forward. Here he says just fill all the buckets. Then you start editing the buckets, and he actually recommends to edit them in the reverse direction from the end to the beginning. And like whatever, this is a process, but you split the job in buckets and in steps, and you make each step simple and easy to finish. In this case, he recommended for each bucket is about 3/4 of a page. So I have a title, and you just have to write something on this like topic or on this title for each bucket. Very easy to do. Job is well defined. And you can do similar approach when you're creating PowerPoints, project plans, and anything else. And this approach works. Another example is similar approach used by teachers in schools with kids with special needs, like slow kids, right? If you ask a child like that to draw a picture of a ship, he will not be able to do it, and he will get upset and maybe crying. But you can make a simple step-by-step plan for the child. So first step, get a box of pencils. Second, sharpen the pencils. Third, get a sheet of paper. Fourth, get a book with pictures of ships. Next, select a picture you like, and so on. So you make these small steps, and the result is that the child can follow this plan, he can do the steps, and he successfully creates the picture, and he's very happy and proud. What you will find working with people, that different people require buckets of different sizes. Some team members can execute the high-level command, like draw a ship, all by themselves. You don't have to micromanage them. But others, they really need a step-by-step plan, and sometimes very detailed plan. It doesn't make them useless. They actually may be very, very effective, but they need your help to give them the plan. So a good manager should calibrate the size of the steps individually for each team member to make them effective workers. Again, very simple advice, very simple to do, but just don't neglect it. Okay, next one, first principle thinking. And then it goes into some simplicity. So first principle thinking is thinking from scratch, actively questioning every assumption. First principle thinking means to reverse engineer complicated problems, break them down into basic elements, and then reassemble them from the ground up. It requires courage and going against rules and against everybody else, against the crowd. I really like this quote, never be afraid of doing tasks you are not familiar with. No ark was built by an amateur. Professionals have built the Titanic. Have no idea who coined this phrase, but it's a genius. And I really like another one. The safest way to go on strike and achieve nothing is to do everything by existing rules. So you have to break the rules. And the term first principle thinking, I first heard from Elon Musk, interview with him. And well, he's famous for this, and he uses this type of thinking in anything he does. If you look at the design of his cars, or how he was designing or is designing the rockets, and really like fresh approach, you can see it. This is Elon Musk. So this is a picture where you can actually see me. I am here in the gray jacket, the shortest one. And this is the Dim Borovikov. This is Sergei Nikitin. He was a medical doctor. So we designed together a portable medical device to register signals from nerve fibers and muscle fibers in human body. So we had a prototype, which was a huge monster machine, very heavy, very expensive. And we converted it into this very small machine. So there is a Toshiba laptop, and under it, in a plastic tray, we have this printed circuit, printed board with some components. Well, here there's no components, there's just the board. So the thinking was that we didn't copy this machine. We decided, well, how we would do it if we'll do it from scratch. And we moved all functionality into software and only left in hardware what absolutely needed to be there. And even this hardware we minimized, simplified, made it lighter and simpler. And we actually managed to do the first working prototype in about like 2 months or 3 months. It was really, really fast. What's interesting that there were several other companies in Moscow who also tried to develop similar device, but they never finished. One of them was a National Institute for like medical equipment, and they had a team of about 100 people, and they had millions of dollars in connections with other countries and manufacturing facilities and like everything. They were actually the national authority for testing medical equipment. I had to take this device to them to test for medical safety. And they had this project to create similar device. They never finished it because they made a big plan, lots of people, lots of money. And instead of making it simple, they made it bureaucratic and complicated and just never finished. Okay, so simplicity. Here are some quotes about simplicity. There are two ways of constructing a software design. One is ways to make it so simple that there are no obvious deficiencies, and the other is so complicated that there are no obvious deficiencies. The first method is far more difficult. So to make things simple, it's actually difficult, and you have to think about it. You have to stop and say, well, am I trying to copy what other people are doing? This is wrong. Like how I would do it, like in a simple way, how I can do it differently. Make everything as simple as possible, but not simpler. It's Albert Einstein. Thank you, Lord, for making all necessary things simple and all complicated things unnecessary. This is a Ukrainian poet, Skovoroda. Like, I just love this quote. Any intelligent fool can make things bigger, more complex, and more violent. It takes a touch of genius and a lot of courage to move in the opposite direction. Well, this is Albert Einstein. KISS principle, keep it simple, stupid, largely used by military, attributed to Clarence Leonard Kelly Johnson, who worked for Lockheed Martin. And the last quote is very, very important. It's by Philip Grinspoon. He is an MIT professor, and he wrote a book on how to do web applications about 20 years ago. Lots of humor. You can still find it online. And his idea was, so you can see that with simpler toolkit. By the way, his toolkit was Oracle database, Tickle script, and AOL web server. Well, America Online nowadays kind of disappeared, but back then it was very big, and they had a web server which was very simple, but at the same time very reliable and scalable. Oracle, it's a good database, right? It's very reliable. And Tickle is a very simple scripting language. With these three tools, they were able, and three people, only his team was only three people. They managed to make big applications very fast, very effectively. So what you're saying, you can see that with a simpler toolkit, the amount of extension programming goes up considerably. You have to do a lot of stuff like manually. What you don't see is that the total implementation effort may be much lower because the underlying toolkit is much simpler. There, the programmers need spend much less time reading documentation, fitting their new software into the old, and etc. Sometimes less is more. So this is a lot of wisdom in this, and that's why I like simple frameworks. Less features is okay as long as you have flexibility to customize and do what you want to do. Okay, prioritization. Well, this is Warren Buffett and his famous 5-25 rule. So what he advises is write down 25 tasks you think are important, prioritize them, choose the top 5, and do only them, and the others just completely remove. Never do them, never think about them. You have to sacrifice. So the main idea is you have to throw stuff out. You have to decide that you will never do something, even though you think it's important, but you cannot do everything. So this is very important. Your success depends on being focused on the most important task features. Your success depends on cutting off all task features which are secondary. And common reason of failure is that people spend time on doing things which shouldn't have been done in the first place. And this is actually a definition of insanity, trying to do something very well, which doesn't have to be done in the first place. Many projects failed because their architects failed to make things simple. They tried to make things right, which is a curse word. As a result, they have built systems which were never quite operational and couldn't survive change. Find simple ways to do things. Try to find a way to complete project in 2 weeks. If you can't see that you can complete the project in 2 weeks, don't do it at all. Think first. Because if you think it takes 2 weeks, it will take 2 months. And if you think it will take 2 months, it will take a year. And in the middle, your boss will realize that it should be done differently, and thus you will never finish the project. Well, fuck it, we don't need it. I mean, this is extremely important methodology. Simplify the design, sacrifice some features. Do we really need it? Often 10% of features take 90% of your programming time. By sacrificing the features, you may make your project 10 times simpler. And I'm not joking, this is really how things work. Some principle can be applied to the features of programming architecture. Trying to make perfect code or complete architecture may make your project 10 times more complex and useless. I really like Joe Sugarman, who is a pioneer in marketing. Well, his definition of pioneer is somebody who has arrows in his back. So, and he also coined the ELF. ELF means easy, lucrative, and fun. So his idea of doing marketing business is somehow to figure out how to make it ELF, easy, lucrative, and fun. And I guess this same approach should be applied to building IT systems. Unix is a shining example of simplicity of design. So Ken Thompson here is the person who is, well, he created Unix. Well, at first by himself, and then Dennis Ritchie helped him. And everything in Unix is very simple. and his languages. His first language, I think, was called A, next was called B, and then with Dennis Ritchie, they created a language called C. And Unix consists of small pieces, small utilities, which you can make work together in infinite, like different ways. But in the core, it is very, very simple, and that's why it became so common and so influential. So I just want to emphasize that why simplicity is so important, and why big monolithic systems like Microsoft Windows didn't survive competition. And now look at Azure cloud, machine learning or whatever, Synapse, under the hood, it's all Linux, Linux, Linux. We have 2 billion Android devices which are Unix based. We have all Apple phones, iPads, which are Unix based. We have all the servers in the clouds, and again, Unix based. Macs, Unix based. You have Unix everywhere because of simplicity. So Unix is a toolbox. It's not a finished application. So it was designed as a minimalistic set of small basic utilities. Well, okay, I already told you this. So you have to decide very carefully whether you really need to deliver finished application, or the client will be much happier with the toolbox, right? It is 100 times more difficult to deliver finished application because you have to test all supported platforms and so on. The bigger the client, the more flexibility they may require. So it actually is strange that for a bigger client, they may be happier if you provide them with a toolbox. Each individual model can be small, manageable, and reliable. The custom application as a whole will be probably built by the client, so you don't have to provide customer support on its quality. Thus, by shifting your goal from making a compiled product to making a toolbox, you made your work much simpler and easier, and at the same time, you made yourself 10 times more valuable in the marketplace. So this, again, very interesting point of view. Simplicity versus dinosaurs. So big, complex systems remind me of dinosaurs. Do you remember what happened to them? And who is now dominating the earth? Well, smaller animals. So distributed systems and simplicity. When you think about organization which is really, really big, you cannot write one application which does everything. So different departments will be using different applications with different functions. It's like a living organism which consists of different organs, but they need to communicate with them. And you need to create like guidelines, systems, rules, formats of messages, of how they send data and how they communicate. And we see it's now happening well, everywhere in the cloud. Anyway, so but individual pieces may be simple, and the rules of communicating may be simple and should be simple. So simple versus right. So you always face two conflicting requirements. Systems get larger and more complex, but systems need to change more often, and changes should be made faster. When things change faster and faster, simplicity becomes a live or die requirement. In many situations, you literally don't have enough time to make things right or complex or even completely finished. What do you prefer? A simple system which does the job, or a system which is architectured correctly but never quite works and can be adapted to your requirements fast enough? So don't try to make things right, make things simple instead. And okay, simple and complicated. Okay, so simplicity versus politics. Well, what I found from sad experience, that managers actually want complicated things which cost millions of dollars, which will require a lot of hiring, building big team. It looks like something very, very important, and they make their career on doing that. So I literally seen situations where the problem could have been solved by writing a small shell script, and instead company would spend millions of dollars and big teams to try to solve the same problem. It's ridiculous, but managers are not stupid. They want to like go up. So they're thinking about their career, and from their career standpoint, they're doing the right thing. Well, it's not the right thing for the company. It's not the right thing for like from like architectural software point of view. But I've seen that by even proposing or mentioning, like verbalizing a simple solution, you can get fired, literally, because you're stepping on somebody else's toes, interfering with their plans. And of course, they will never tell you that. They'll just fire you. Okay, growing a project as a child. So let's say you started a web page with one page, and then you added some more, and you're working one page at a time, and each page is a finished product. Remember, step by step, bucket by bucket. Together, pages make a system, and it's your website. The system growth is stable. You always succeed because each step is simple and rewarding by itself. This is example of evolutionary development. You start from a simple bare bones single function utility, then you write another one and another, you add features, you combine them together, and finally you have a product. You allow the program to grow as a child. And when the child is born, you don't know exactly what it will grow into. Maybe the product itself will not be a success, but one of the components will. The art is to sacrifice the development process, to structure the development process into a set of easy and rewarding small steps. The art is to structure the development process so that the product starts to be useful at early stages, and then its growth, it grows and improves with the feedback from users. And again, simple, but I've seen so many times when people want to try to predict an architecture like too early. I'm all for like growing a child. If software is simple and useful, it can start with a 2-week project and then grow as a child. If software is not simple or not useful, it will be very difficult for it to grow or even survive, regardless of how much time and money were originally invested or how right was its design. I wrote this and then found that I was not the first who formulated this. See example on this website, Worse is Better, by Richard Gabriel. Okay. Next example will be the last slide today. And this is this example, hacker versus architect. So let's say you need a report. So you asked 2 programmers, John Hacker and Bob Architect, to create this report. John Hacker hacked a script in 1 hour and emailed you the report. You looked at the result and realized that your original requirements were not correct. So you asked to make changes, which John emailed you in the next 10 minutes. After going back and forth 5-10 times, you were completely satisfied. You could customize the report providing some simple parameters on the command line or in a short text file. John sent you all the scripts along with the short README instructions, and the project is done. He also put the scripts on the web server and made a simple web page for you to run the report in the browser and either download it or receive via email. So as you see, very simple and very fast and customized for the client. The alternative approach, Bob Architect. So he's a true believer that if you do things right, it will save you effort in the long run. And this statement is completely wrong. So he started with drawing UML diagrams using rational rows or together J to make proper object-oriented design. I don't know, like if there are Java people, like they will understand all this terminology. Design of the report engine. He also decided to make a proper GUI interface for the application. At the time when John Hacker went through 10 revisions, Bob Architect was still busy thinking about distributing responsibilities between his classes and interfaces, and was very proudly telling you about his elegant design of request manager and cache manager and report manager. Finally, he made the application work, but it took him 10 times longer than John Hacker. And when he finally finished it, you already needed a different report. So you ask him to change the reports, and he said it will take him a long time because your new requirements don't fit well into his object model. So he will have to start from scratch, basically. So this is like really, really familiar. I've seen it multiple times. In this scenario, first programmer sacrificed some features like GUI, object-oriented design, which allowed him to complete the job much faster. And then to use users' feedback to make multiple changes to make the product good for the user and easily maintainable. So again, I've seen both approaches and kind of learned from experience that the left approach with John Hacker is much more effective and much better for the work, for the client, for the business user. And that's it. We have just a couple minutes left. I will try to stop the recording if I will remember how to do it. Okay,